Hello and welcome. In this video I'm going to show you how we can find the second derivative of a function using implicit differentiation. Find y double prime by implicit differentiation for the following relations. The first relation is this: 4x to the 2 plus 9y to the 2 equals 25. As you can see here, we have an implicit relation and we want to find y double prime. For finding y double prime, first we have to find y prime, and then we have to take the derivative of that with respect to x again for finding y double prime. So let us start with finding y prime. Because this is an implicit relation, we use implicit differentiation method for finding y prime. So first we take the derivative of both sides of the relation with respect to x. Derivative of 4x to the 2 is 8x. The 2 multiplies by 4 by the power rule. The derivative of 4x to the 2 is 8x. The derivative of 9y to the 2 is 18y. But don't forget, because in implicit relations, we suppose y to be a function of x. So we have to multiply it by the derivative of the y always. Multiplied by y prime. Don't forget this. So derivative of 4x to the 2 is 8x. Derivative of 9y to the 2 is 18y prime. Always when we take derivative of the terms involving y, we have to multiply them by derivative of the y, which is y prime. And derivative of 25 is 0. So from this, we solve this equation for y prime to find y prime. If we move 8x to the other side, or in another word, if we subtract 8x from both sides, we have 18y prime equals negative 8x. If we divide both sides by 18y, then we have y prime equals negative 8x over 18y. If we simplify numerator and denominator by a 2, we can write y prime as negative 4x over 9y. Now, for finding y double prime, we differentiate both sides of this relation again with respect to x. Derivative of the left side, derivative of y prime, is y double prime. And we want to find y double prime. We take derivative of y prime again with respect to x, and derivative of y prime with respect to x is y double prime. So we have y double prime equals derivative of this with respect to x. But don't forget that again, when you are finding derivative of this, remember this is like an implicit relation. So when you take derivative of y, don't forget to multiply it by y prime. And of course, because here we have a fraction, we need to use quotient rule. So let us start finding the derivative of negative 4x over 9y with the quotient rule. The derivative of numerator is negative 4 times by denominator minus, write whatever is in numerator, multiplied by derivative of denominator. The derivative of 9y is 9y prime all over 9y to the 2. Let's simplify this. We have in numerator negative 36y plus, minus times minus is plus 36 x y prime all over 81y to the 2. Attention, here we have to do something to find y double prime. Y double prime is this, but here we have y prime, and from this we know that y prime is negative 4x over 9y. So we have to replace this y prime here with this expression. So y double prime equals to negative 36y plus 36x times y prime, but y prime is negative 4x over 9y all over 81y to the 2. Attention here, we can simplify 36 by 9 here. If we simplify 36 by 9, here is 4 and the 9 is gone. So we have this expression for y double prime equals negative 36y plus, we have a 4 here, 4 times negative 4x is negative 16, so negative 16 x to the 2, y x to the 2, because x multiplies by x, so we have x to the 2 over y, don't forget we have this y in the denominator, all of this over 81y to the 2. So I have to put this y double prime here. Now for simplifying this numerator here, you can do a common denominator between this fraction and this term. But the better way for simplifying the numerator is to multiply numerator and denominator by y. By doing so, you can get rid of this denominator here. This is better than doing a common denominator in numerator. If we multiply numerator and denominator by y, then y double prime is negative 36 y to the 2, y multiplies by this. When we multiply this y by this term, the y and the y cancel, so we have minus 16x to the 2, and in the denominator we have 81y to the 3. So this is the simplified form for y double prime. But let me remind you, the given relation was 4x to the 2 plus 9y to the 2 equals 25. Let me write it down here. So we know that for this curve, x and y satisfy this relation, 4x to the 2 plus 9y to the 2 equals 25. I want to use this relation between x and y for simplifying this numerator. And again, I should mention this, that all of this simplification that I am doing here is not really necessary, but it's good to learn these type of simplifications. If you look to your numerator, you can factor a negative 4 in the numerator. Then we have this negative 4 times 9y to the 2 plus 4x to the 2 over 81y to the 3. Look at the inside the bracket and look at here. The expression inside the bracket is exactly this. And we know that for every x and every y for this particular curve, 4x to the 2 plus 9y to the 2 is 25. So we can replace this expression inside the bracket by 25. If we do so, we can write the y prime in this form. Let me write it here. We can write finally y double prime equals, because this is 25, negative 4 times 25 is negative 100 over 81y to the 3. And this is the second derivative of that implicit relation in the simplified form. Now look at this implicit relation. X to the 3 minus y to the 3 is 12. We want to find y double prime. First, we start by finding y prime. We take the derivative of both sides of this relation with respect to x. The derivative of x to the 3 is 3x to the 2, and the derivative of y to the 3 is 3y to the 2 y prime, and the derivative of 12 is 0. If we solve this for y prime, then we have 3y to the 2 y prime equals 3x to the 2. If we divide both sides by 3y to the 2, y prime equals 3x to the 2 over 3y to the 2. The 3 with 3 cancels, so finally we have y prime is x2 over y2. This is the first derivative, or y prime. But we want to find y double prime. For finding y double prime, we differentiate both sides of this relation again with respect to x, and we use quotient rule and implicit differentiation technique again. The derivative of y prime, derivative of the left side, is y double prime. For finding the derivative of the right side, we use the quotient rule. The derivative of numerator is 2x times by denominator minus write the numerator and multiply by derivative of denominator, which is 2y prime. Don't forget y prime. When we take derivative of y, we have to multiply it by y prime because y is a function of x. Y is not a simple variable. Y is the dependent variable. So we have to multiply by derivative of y, which is y prime, all over denominator to the 2, which is y to the 4. Y to the 2 to the 2 is y to the 4. So finally we have 2xy to the 2 minus 2x to the 2y y prime over y to the 4. First of all, don't forget to replace this y prime with this expression. But also note that you can factor a y from numerator and cancel that factor with the denominator. These are the two important things that definitely we have to do. So y double prime equals, if we factor a y from numerator, then we have 2xy minus 2x to the 2y prime over y to the 4. If we cancel y from numerator with one y from denominator, then we have 2xy minus 2x to the 2y prime over y to the 3. But we have to replace the y prime with x to the 2 over y to the 2. So we have 2xy minus 2x to the 2 times x2 over y to the 2 all over y to the 3. For simplifying this expression, again, we multiply numerator and denominator by something that help us to get rid of this, because we don't like to have fraction in numerator. To get rid of y to the 2 in this fraction in numerator, we multiply the numerator by y to the 2, and of course we have to multiply the denominator by y to the 2. If we multiply the numerator and denominator by y to the 2, then y double prime equals to, multiply this by this, 2xy to the 3 minus, this cancels with this, so only this remains, minus 2x to the 4 all over y to the 3 times y to the 2 is y to the 5. So this is y double prime for that implicit relation. Again, if you remember, x to the 3 minus y to the 3 is 12. So we know that x to the 3 minus y to the 3 is 12. Let's see, can we use this again for simplifying our answer or not? Look at the numerator here. If you pay attention, you can factor a 2x in numerator. So we can write y double prime like this. 2x times y to the 3 minus x to the 3 all over y to the 5. X to the 3 minus y to the 3 is 12. So y to the 3 minus x to the 3 is negative 12. If you multiply this by a negative, you get this. So if you have to multiply this also by a negative. So because x to the 3 minus y to the 3 is 12, y to the 3 minus x to the 3 is negative 12. And so if we replace the bracket with negative 12, we can write our answer in this form as well. So y double prime equals negative 24x over y to the 5. Now look at this question. Sine of x plus cosine y equals square root of 2. We want to find y double prime for this implicit relation. First, we have to find y prime as usual. So we take derivative of both sides of this relation with respect to x. Derivative of sine x is cosine x. Derivative of cosine y is negative sine y. Don't forget to multiply by y prime, and the derivative of the right side is 0. If we solve this for y prime, then we have sine of y times by y prime equals cosine x. If we divide both sides by sine of y, then we have y prime equals cosine x over sine y. So this is the first derivative of that implicit relation. But we want y double prime, so we have to take derivative of both sides of this relation with respect to x for finding y double prime. Derivative of y prime in the left would be y double prime. And for finding derivative of the right side of the equation, we use the quotient rule. Derivative of numerator is negative sine x multiplied by denominator minus, write the numerator and multiply it by derivative of denominator. Derivative of sine y is cosine y multiplied by y prime, because sine of y is a term involving y. Always when we take a term involving y, we have to multiply its derivative by y prime all over denominator to the 2 sine of y to the 2. Now here we have to replace the y prime with its answer. Y prime is cosine x over sine y. So we can write our answer in this form. Y double prime equals negative sine x times sine y minus cosine x times cosine y times by cosine x over sine y all over denominator sine y to the 2, which we can write it as sine to the 2y. Again, for simplifying numerator, and to get rid of that, we can simply multiply the numerator and denominator by a sine y. And don't forget to multiply sine y in denominator. Then y double prime is, denominator is sine to the 3y. If we multiply this by this, then we have negative sine x sine to the 2y. This cancels with this and only this part remains. So we have minus cosine to the 2x, cosine x times cosine x is cosine to the 2 times cosine y. And this is the answer for y double prime for this implicit relation. I hope you liked this video. If you like this video, please subscribe in my channel and see you in the next videos.